Welcome to the Level 1 Quantitative Methods Summary video series. This video is a summary of the Quant reading on probability concepts. This is an area that many people have issues with, and later in the next segment I'll go over some probability questions. At this stage I'll give you a couple of pieces of advice. You need to understand and remember the terminology, and you need to remember the formulas. Then when you get a question, just before you get confused by the question, just regurgitate the formulas and then read the question carefully and then figure out which formula to use. Sometimes people read the question and then forget the formulas. So before you forget the formula, just write the formula down. And there are not that many formulas. So these are the basic terms which are fairly obvious. Very often you hear the term that these events are exclusive and exhaustive. Mutually exclusive and exhaustive means that the various events cannot happen at the same time. So if you flip a coin, then heads and tails are mutually exclusive in the sense that you can't have heads and tails at the same time. And they are exhaustive in the sense that if you flip a coin, you'll either get heads or tails. In the context of stock returns, you might say that on any given day, the stock return will either be greater than equal to 0 or less than 0. So if I define those two events, they are mutually exclusive and exhaustive. Remember these terms. Empirical probability is a probability that is arrived at based on analyzing data. A priori probability is calculated by using formal reasoning and inspection. And subjective probability is less formal, it involves judgment. Remember that. Unconditional probability is the probability that a given event will happen regardless of anything else, and it's denoted like this. Conditional probability is denoted like this. This is the probability of A happening given that B is happening. The moment you see this bar, that means that it's conditional. So this is probability of A given that B has occurred. Independent events, so occurrence of one event does not influence the other, and with dependent events, knowing the outcome of one tells you something about the other. So if A and B are independent, then probability of A given B is equal to probability of A. Because if we are saying that A and B are independent and B happening tells you nothing about A, then probability of A given B will be probability of A. On this slide, I have put down all the probability rules and formulas except for the base formula. Right? So at least memorize these. The multiplication rule is shown right here, and then for each formula I have done a quick little example. Then this is the addition rule. I have already mentioned this. Independent events, occurrence of one does not influence the other, so we have talked about this. And then for independent events, the multiplication rule becomes this. So if I have a die and I roll it once and then I roll it again, are those two events independent? Yes, because the first roll has nothing to do with the second roll. So if the first event is getting a 6 and the second event is getting a 6, what's the probability of getting a 6 and a 6? It is 1 over 6 multiplied by 1 over 6. So the multiplication rule becomes quite straightforward when we have independent events. And this is the total probability rule, where we say the following: the probability of a given event, is this independent or dependent? Probability of A?
Independent.
It is independent. The total probability rule allows you to use dependent events. So you say you are given dependent events and you need to compute the probability of an independent event. That's where you use the total probability rule. So if you have scenario S, which is the economy will be good, and scenario not S, which is the economy will not be good, are S and SC mutually exclusive and exhaustive? Yes, the way I've defined it, they are. Then you can use this. You can say probability of A given S into probability of S plus A given not S into probability of not S will give you probability of A. If I have 3 different scenarios, then instead of having 2 terms, there will be 3 terms. And we'll see this in the next segment where I'll do some questions involving this rule. But again, I'll reiterate, the moment you see a probability question, first thing that should go through your head is this Bayes formula or not Bayes formula? If it is not Bayes formula, then write down the multiplication rule and the addition rule before even trying to figure out which rule to use. And I say that because very often the way the questions are worded, they tend to be confusing, but you write down the formulas, you write down the data in terms of these symbols, and then given the data and given the formulas, you need to figure out which formula to use. And obviously that will come with some practice. Next point has to do with computing expected value and standard deviation of a random variable. Now you might think that you've sort of done this, but there is a difference. In the earlier discussion on standard deviation and variance, what we said is that we are given a data set, you plug the data set into a calculator and you came up with the standard deviation. Now the difference is that let's say that you have a variable such as a cash flow, where the cash flow depends on the state of the economy. Each state of the economy has a probability. So there's a 0.3 probability that the cash flow will be 50 and so on. Now, does this cash flow have a variance or is it constant? Clearly it has a variance, but each of these cash flows is not equal probability. There are different probabilities. When you have different probabilities, you can still calculate the expected value and variance. Expected value is simply 0.3 into 50 plus 0.5 into 40 plus 0.2 into 20. And the variance is a measure of how spread out this data is. And I would recommend that you do this using the calculator. There is also a formula for this, but this slide essentially shows you what you need to plug in, and that is going to give you both a sample and a population variance. And this, by the way, is a population. And how do we know that? Because we are defining that there are only 3 possible states of the economy, and we are given the cash flow for each state. So this covers everything and is therefore a population. Covariance, correlation, portfolio return, and risk. The covariance is a measure of how 2 variables move together. Values range from -infinity to positive infinity, and this is the formula. Later I will do a question where we calculate the covariance. This looks long-winded, but I'm quite sure that if you get this on the exam, it will be based on relatively straightforward numbers. So later we'll see how to use this formula. The issue with covariance is that it spans from -infinity to +infinity. So if you have a covariance of 38, you know that it's positive, you know there's a positive relationship, but you don't know whether you have a strong positive relationship or not. In order to figure that out, you need correlation, which is a standardized measure of covariance. So the correlation is the covariance divided by the standard deviation of each of the variables. This is the expected return, which I've talked about before. It is simply a weighted average of the returns of, let's say, 2 different stocks. And then this is the variance of returns of a portfolio. You need to remember this formula. And in one of the examples in a video that I've already shared, this has been calculated. This material also shows up in portfolio management, so it is important. Okay, now coming to everybody's favorite topic, Bayes formula. Many people have issues with this, and later I'll do a couple of questions related to Bayes formula. In the picture that I showed you earlier, the one that looked like this, I would not put Bayes formula over here. It is somewhat difficult. I'd put it a little later, but I still like to cover it because it deals with many of the probability concepts that we've talked about, especially the total probability rule. I'm not going to explain this in detail now, but in case it shows up, I'll tell you how to deal with such problems. The first thing that you do is you remember this formula. Probability of event given information is equal to, the starting point is the original probability of the event, and then you are going to change this based on the new information. And how do you change it? By multiplying the original probability of the event by probability of information given event divided by the unconditional probability of the information. Very often you will not be given this, but you will have to use the total probability rule to come up with probability of information. And typically this will be given and this will be given. Now in the next segment I'll actually make you do 2 questions, but for now I will emphasize that at least memorize this formula. Even if you don't thoroughly understand Bayes' formula, then knowing the formula can help you answer most questions.
So sir, is it better that for the Bayes formula questions we use the tree diagram? Because if we use the tree diagram, then it will be less complicated. Because
okay, so the question is on the Bayes formula, do we use the tree diagram?
We can use that.
We can. My response to that is that different people find different things easy.
Yeah.
So if you like the tree diagram and that helps you answer, I know some people like doing it that way, then go for it. So you have to practice and figure out what works for you. Okay, next, permutations and combinations. Here again I strongly encourage you to use the formula. When we talk about permutations, NPR, or let's just say that in a portfolio of 8 stocks, then N would be 8, and we want to choose 3 of those stocks to sell, and the order matters. Let's say that if you start selling, there'll be a huge issue. So the order in which you pick the 3 from 8 matters. When the order matters, then we have a permutation. So the formula would be 8 factorial divided by 8 minus 3 factorial. But rather than use this formula, I want you to use the calculator. So the way you do this is you plug in the 8, then second, then this NPR, and then you plug in the 3. So that will give you the answer. With combinations, the order does not matter. So if you are doing a 6C4, then you do a 6, second, and NCR is right here, and then 4. So use your calculator.